his mask.
All right, I don't think we missed one on the front. Did we get any right on the back?
Yeah, we had a couple.
I
don't know, I got them.
Right.
2 of them.
No, I don't think we got a single one of them.
Yeah, I don't think
No,
any of them.
we were over the back.
I'm pretty sure.
Okay, that happens.
It's kind of awkward.
That happens. Keeps me employed. Keeps me employed. So, all right, we got them all in the front, but that doesn't mean you don't have a question. Does anybody need to, if you need to know how to do 7, you need to know how to do 8. I mean, you need to know how to do them all, but some are gonna show up more often than others, I should say. Specifically, like 7, you need to make sure you know how to do that.
We need 8.
You need 8?
Yeah.
Just trying to think what I want to ask here. The minute hand is moving 10 minutes, or basically from like a 12 to a 2 or 2 hours. What's that? Do you know what that degree is?
No.
No, all right, that's my question. If you look at a clock, what is the degree between 2 hours, like between the 12 and the 1, between the 1 and the 2?
Good question.
The full circle is 360 degrees. It's broken up into how many parts?
12.
12. What's 360 divided by 12?
What is that?
30.
Yeah.
So every hour, like if you draw a central angle, it will be 30 degrees. Well, if it's moving 10 minutes, oh, that's not a good spot for that. Okay, and I'm just 12. 1, 2, 3. And think about it, from 12 to 3, that's going to be 90 degrees, right?
Mm-hmm.
But from 12 to 2, so that 10-minute arc, that's going to be 60 degrees. Well, S equals R times theta. The R would be the length of the minute hand, which is 7 inches. Theta, we got to put into radians. The 60 degrees, change that to radians with pi over 3. So 7 times pi over 3 will give us 7.33. Okay, for that one.
Look at this, because I still got the right answer.
Well, yeah, as long as you get the right answer. I don't know how to do it.
Yikes. That's difficult.
Yep, that's perfectly fine. Perfectly fine. All right, now on the back, number 9. Yes, number 9 is important. Definitely. And here's where a lot of people got off is, if you pay careful attention, they're all over the place with the units, especially, in each problem. I don't think there may not be 1 or 2 problems that have the same units. What I mean by that, they got the diameter is 28 inches, but what are they talking about the velocity? They're talking that is feet per minute. So you got to make sure those are the same. All right, how do we determine the RPMs in this case? All right. What do we got to do? Because you need to know how to do this. The belt is moving 1,051 feet per minute, so it is turning that. So essentially a point on the rim, like if you would roll it out, it would roll how many feet in a minute? 1,051. That's essentially the linear distance it's going to cover. To find the RPMs, the revolutions, you need to take the distance. Basically, it travels divided by the circumference of the pulley or the tire or the wheel. That'll tell you how many revolutions it made. Well, we got to make sure they're in the same units. If it traveled 1,051 feet, that means it traveled 1,051 times 12 inches, since our circumference will be in inches. And the circumference is 2 pi times 14. 2 pi times 14. All right, put that in your calculator. Make sure you get 143 rounded. Okay, don't enter it incorrectly. You had it.
Yeah.
You what?
We did V equals whatever, some X and then It worked.
It worked. That's fine. Fine. 143, right?
Yeah.
143 revolutions, in this case per minute. Okay, for that. All right, number 10. Okay, the pulleys will be proportional, and some of you may have just done that, but I want you to prove to me they're proportional. What I mean by that, if the larger one is going 35 times per minute rotating, and the smaller one is half as big, it's gonna double the number of revolutions. It's gonna double to 70, but how can you prove that? Or verify it or validate it? So here's what I'm gonna ask you. So this one went 35 revolutions. Turn. What would be the linear distance it covered? Okay. So basically that belt, after 35 times, like if you would just lay the distance down, how would you figure out how far it traveled? Jaden, what do you think? Do you know how to do that, I guess is the question.
Find the circumference and
then do what with the circumference?
times it by the rotations.
Good. So take your rotations, which is 35, times the circumference, which is 2 pi times 3. Do that, but keep the pi. What's 35 times 2 is 70. 70 times 3 is 210 pi. Okay, it'd be about 659.7. In this case, inches. I want to leave it in terms of pi because I know what I want to do here. How many revolutions is that going to be for the smaller one? What do you have to do? Same idea. You got to take the distance divided by what? Distance divided by circumference. So to find the revolutions of the smaller one, take your distance divided by the circumference. Distance is 210 pi. What is the circumference? It's 2 pi times 1.5. And then what is that going to give me? Revolutions is going to be 1.5 times 2 is 3. You're really taking 210 divided by 3 because the pi's cancel. And what do we end up with? 70. 70 RPMs. So if the bigger one is traveling 35 to kind of keep up, it's got to run faster. So he's going to go 70. Well, what does it actually ask us for? It asks us for the angular speed. Every time it makes a revolution, it goes 360 degrees or 2 pi radians. So you multiply 70 times 2 pi. So my angular speed is 70 times 2 pi, or 140 pi radians per minute in this case, okay? Radians per minute. All right, 11. This one can be done pretty handily with V equals R times omega. 5 radians per second is actually what? That is the angular speed, which is which variable up there?
W.
Yep, it's that omega, that W. So omega is 5. What is the radius of the wheel? Radius of the wheel is what? 15. So the velocity is 15 times 5, but what, and that's 75, and what are the units? According to what we got. If it's 5 radians per second, and we got a 30-inch diameter wheel, it's going to be inches per what? Second. And what do they want the units to be in? They don't want inches per second, they want feet per minute. And so now it's just a conversion problem. Okay. That's the velocity problem. After that's a conversion problem, it should end up being 375. Okay, you gotta take 75 divided by 12. to give you the number of feet, take 12 times 60, or no, take that answer, which is 6.25 times 60, to get the, what do we say, 375? Volume equals 375 feet per minute. Okay. All right, anybody actually get 12? Robert, good work. Okay. Here's what I want you to do. Take 12 miles per hour. Everybody do this now. Convert it to inches per second. And then just stop. So take 12, and you can do it other ways. There's different ways you can go about this, but see what you get for inches per second. Okay, what would that be? Okay. Oh.
60. This is not right.
Zachary, you got it? Almost there. Let me know what you get. 12 miles per hour. I'm going to do this conversion thing, which I'm not very good at. 5,280 feet in 1 mile. 1 foot here. 12 inches. 1 hour over, I'm going to cheat and make it 3,600 seconds. So I think that'll work.
Uh, 211.2.
Yes, 211.2 inches per second. 211.2 inches per second. Now we need to go, theta, the angle, equals S divided by R. That would be the length it's traveled, okay, in 1 second, which is going to be equivalent to what in the theta equals S over R. That's going to be our arc length. Now there's a couple different ways you can go about finishing this problem, but let's figure out, if I do this, if I do 211.2 divided by, what is the radius of the wheel? 18. What is 211.2 divided by 18? That is 11.73 repeating. Okay, that's 11.73 repeating. And that would be radians per second. That would be radians per second. Well, that's obviously not the answer, right? Well, because it says for how long did the tractor travel?
12 miles.
That was the speed.
Wait.
25 seconds.
Oh.
So that is per second. So some people either multiply the 211 times 25 and then divide by 18, or you can divide by 18 and then multiply that by 200 or by 25. So 11.73 repeating times 25, that is where we get the 293.3 radians. So after 25 seconds, that's where we would be. Okay. That's where we would be. All right, for 13 and 14, if you have any issues fixing that, let me know. But I want to pass out the guided notes. We're going to roll into section 5.2. Little right triangle trig. Some stuff you are been exposed to before.
Thanks.
Oh, you're welcome.
Thank you very much.
Oh,
That is fun. This is all I signed up for. I signed up for geometry.
what's that?
I signed up for geometry. No.
No, it's true.
No. We learned this in geometry. This is supposed to be pretty good. Oh my god. I hate trigonometry. With a pad. You like it? It's easy. Yeah. Improves. That's a good part of geometry. That's the worst part. Sorry.
I'm not worried about it. I'm not worried about the rest of it. And they both.
Alright, you probably were at least exposed to SOHCAHTOA. That's just kind of the one you might to help you remember. Like I said, we're just starting to to build up the unit circle, to build up trig of any angle. We're gonna start with acute angles. We're basically all started with triangles. What's the O and the H stand for? O stands for
Opposite.
opposite, you remember. H is hypotenuse. Alright. Now, you're more familiar with sine, cosine, and tangent because they're used a lot more, but in here, we're gonna cover the 6 ones, which includes cosecant. SEC is secant, and then cotangent. Sine, opposite. Now remember based upon where your angle is, okay, if I identify that as theta, across from it is the opposite. Now when you're labeling a triangle, let me just make sure I highlight this. Capital letters for angles, and then the side across from it, you need to label with a lowercase letter. So if this is angle A, you got to label that as side A. Okay, you just can't randomly put them down. It doesn't make sense. If side C is that, or angle C is the hypotenuse or the right angle across from it, has to be side C. And then angle B is side B. So across from theta is opposite. The adjacent formed it, and the hypotenuse always has to be across from the right angle. So sine is opposite over hypotenuse, which is, in this case, A over C. And we're just going to look at the ratios. Cosine, adjacent over hypotenuse, which is B over C. And then opposite over adjacent, what's that going to be? A over B? A over B. Okay. All right, do you remember cosecant? Not as familiar with that. All right, that's the reciprocal of sine. So you just flip it. It's hypotenuse over opposite. So it's hypotenuse over opposite, which is C over A. And the same thing with secant is going to be the flip of cosine. It's going to be hypotenuse over adjacent, which is C over B. And then this is adjacent over opposite, B over A. All right, so just going through the ratios there. All right, find the exact values for the 6 trig functions of the angle theta. Rationalize denominators and reduce fractions. So I'm going to give you 2 of the 3 sides. I'm going to give you the hypotenuse is 6. I'm going to give you the side on the bottom is radical 11. The angle is this top angle here. You need to find, or we need to find this missing side. And since it's a right triangle, use Pythagorean there. So I'll just call that x. And I got x squared plus square root of 11 squared equals 6 squared. All right, go ahead and find that missing side. All right, Nick, what'd you get? I see it there. 5. Because you're going to get x squared, square root of 11 squared is 11 equals 36. Subtract 11, 25. Take the square root, x equals 5. So we end up with a whole number there. All right, so sine of theta is opposite over hypotenuse. So it's going to be square root of 11 over 6. Cosine of theta, adjacent over hypotenuse. That's going to be 5 over 6. And tangent of theta, opposite over adjacent, opposite of square root of 11 over 5. All right, cosecant then, Zach, what's cosecant going to be?
6 over radical 11.
Okay, do you remember how to rationalize denominators?
Yes, I think you multiply by, is it radical 11 over radical?
Yep, whatever you're trying to get rid of, we multiply by radical 11 over radical 11 because it actually equals 1. And we get 6 square root of 11 over 11. Always try and see if your constants will reduce. They don't here because you got a 6 and 11. All right, secant of theta, Ty, what's that going to be?
6 over 5.
6 over 5. All right, good. And Madison, what's cotangent going to be?
5 radical 11 over 11.
Okay, when we are done, 5 radical 11 over 11. Okay, now, you don't always have to find all 6. So for this one here, let sine of theta equal 5/9 and only find tangent of theta and secant of theta. Now, I know you don't have the picture there. You don't always, or you're not always given it, so, but I think it's always good to draw it. So I'm going to draw this. I'm going to put theta down here, and that means my opposite side is 5, my hypotenuse is 9. All right, go ahead and find that missing side, and it does simplify. It will be a radical, and it does simplify, and then we'll finish it. Okay. We got x squared plus 5 squared equals 9 squared. X squared plus 25 equals 81. I get x's square root of 56. All right, what does that simplify to? Okay, what do you do that? Catherine, you got it?
I got 7.48.
No, I needed, sorry, no decimals. My
Oh.
fault, that's my fault. When you do kind of do the factor tree or whatever. Cole, you get what it simplifies to?
2 radical 14.
So simplify to 2 radical 14 because it's 4 times 14. So in this case here, a lot of like the unit circle and all this we're going to do in terms of exact values. All right, tangent of theta then is going to be opposite, which is 5, over 2 radical 14. What's the only thing I need to multiply by to get rid of the radical?
Mhm.
The radical 14. There's a little bit of misconception. Some people think you got to multiply by whatever the denominator is. That's not the case. Just radical 14 will make it the easiest case or easiest work. So tangent of theta is 5 square root of 14 over I just make sure you get 28 there. Square root of 14 times square root of 14 is 14. Then you got 2. Nothing reduces. Leave that. All right, so secant of theta. That is hypotenuse over adjacent, which is 9 over 2 square root of 14. All right, same scenario. Multiply by radical 14 over radical 14. So I get 9 radical 14 over 28. So depending on what they ask, you might not need to find all 6. Okay, that's for, we don't know what the angle is. We're given a couple sides. Now we want to move into knowing the angles, specifically 45-degree angle and then 30 and 60-degree angle. So we're going to start with the 45. All right, on that picture that you have, we can come up with different triangles that are 45, 45, 90, but probably the simplest will be this case here, where your two sides, remember, if you have equivalent angles, you have to have equivalent sides. So if this is 1, that has to be 1. And using Pythagorean theorem, 1 squared plus 1 squared equals x squared. You get 2 equals x squared. X equals square root of 2. That's how we get the hypotenuse. Okay. But what's the sine of 45? Okay, at least Robert, ratio. What would the ratio be for sine of 45?
It would be 1 over square root of 2.
1 over square root of 2. Now, when you rationalize that denominator, you're going to multiply by square root of 2 over square root of 2. I get square root of 2 over 2. All right, make sure you understand the connection. When you hit sine of 45 degrees, now if you're not in degrees, if you don't get that, make sure you're in degrees for this. When I get 0.707. Understand that is the same as the square root of 2 divided by 2. Okay, they are equivalent. So whenever you see the sine of 45, you can replace it with radical 2 over 2. Cosine of 45, we get the same thing. 1 over radical 2 because it's adjacent over hypotenuse. Simplifies the square root of 2 over 2. Tangent of 45. Tangent of 45 is equal to 1 because you're taking what? 1 divided by 1. So that's 1. All right, cosecant of 45 will be square root of 2 over 1, which is just square root of 2. Secant of 45 will be square root of 2, and cotangent will be 1. Okay, for those. So those are your exact values for 45-degree angle. All right, when you get that, flip it over. All right, what's the exact value for the sine of 30 degrees? Okay, sine of 30 degrees, that's what we want to get to. Now, to kind of develop this, I'm starting with an equilateral triangle. All the angles are 60, all the sides are 2. Cut your triangle in half with a perpendicular bisector. Okay, this is a perpendicular bisector. That'll be a right angle. Now, there's a little bit of geometry going on, but I think we can are safe to understand that it's going to cut that bottom side into 1 and 1. So cut into 2 equal pieces. And what's going to happen to our 60-degree angle? 30 and 30. So we basically created 2 30, 60, 90 triangles. Okay, 2 30, 60, 90 triangles. All right, this hypotenuse is 2. This side here across from the third degree angle is 1. I don't know the height. Can I figure it out?
Yeah.
Yep, all right, figure it out. And I'm going to say I got 1 squared plus, we'll call that h for right now, h squared equals 2 squared. 2 is my hypotenuse. 1 is that side down here. 1 plus h squared equals 4. H squared equals 3. So that height equals the square root of 3. Okay, that height equals square root of 3. All right, all right, so using that figure, what's the sine of 30 degrees? Sydney? 1 over 2. It is, what is the sine opposite to 30 degrees? It is a 1. What is my hypotenuse? It is a 2. And then if I double check on my calculator, sine of 30 degrees says 0.5, 1/2. Any 30, 60, 90 triangle, you take the sine of 30 degrees, it's got to be 1 over 2. Cosine of 30 degrees. Mackenzie, what's that going to be? What do you think? All right, here's my 30-degree angle, right? Which one's the adjacent side? That would actually be the hypotenuse. So adjacent side has to be, so it's going to be square root of 3 over 2. So square root of 3 over 2. Alyssa, what's tangent of 30 going to be?
1 with square root of 3 over 3.
Oh, so you did it. You rationalized in your head.
Yeah.
You're way better than me. So it's going to be 1 over square root of 3, which, as she said, when we rationalize, is going to be square root of 3 over 3. Okay. Cosecant of 30 is the flip of sine. 2 over 1, which is 2. This will be 2 over square root of 3, which becomes 2 square root of 3 over 3. Cotangent will be square root of 3 over 1. Okay, square root of 3 over 1, which is just square root of 3. All right, now you go ahead and figure out sine through cotangent of 60, and then there's no homework. That's all I need you to do. Okay. And then I'll go over here in 90 seconds. Yeah.
Yeah.
Okay. All right. So just make sure that you're good here. Sine of 60, square root of 3 over 2, because you got your 60-degree angle. Right here, opposite would be square root of 3. Hypotenuse would be 2 for that one. Cosine, 1/2. Tangent, that's just square root of 3, right? Cosecant is going to be 2 over square root of 3, but that's going to be 2 radical 3 over 3. This is going to be 2 radical 3 over 3. All right, that's all I got. We'll finish this up on Monday. We'll work through it on Monday. Tuesday.
Yeah.
Tuesday, just kidding. You guys can stay home Monday.
I won't be here.
Don't be here.
So, where's the phone?